So we are almost there. So we will start with the short presentations by the panelists who will introduce their toolkits, right? So I think we can start with Shinji because he needed to go, right? Shinji,
Sure.
yes.
Can you hear me?
Yes.
Yeah, I'll be until 3:30 be here, but yeah, later I have to leave. So
You prefer to go first or last?
sure, yeah, I
First, right?
can do it first. But
Yeah.
also
Yeah.
I have to apologize that I was actually sick in during the interspeech. I don't know some people may heard at the interspeech actually many people caught a cold and
Oh
I was
God.
one of them.
I hope it's not my case, Shinji.
Yeah.
For now everything is fine.
And then the weekend completely I was actually the bed, and then I made a slide just before the 1 hour. So
Good luck.
really apologize for my very low
My
quality.
slides are not very good either.
Yeah.
Oh God.
But anyway, yeah, let me start. Yeah.
Yeah, I will also introduce you. So
Is
maybe
it?
just
Yeah,
feel free to share your slides and then I'll make a short intro.
sure. Yes.
All right. So I guess Shinji doesn't need any introduction, but I'll try to do one anyways. So Shinji is currently an associate professor at CMU, where he's leading a very large lab. I personally met him when I was an intern at Merle several years ago. But he's like, as everyone knows, like he's leading this toolkit called ESPNet that probably everybody's like used and very familiar with. And with that, like I'll leave the floor to you, Shinji, for
Sure.
presentation on ESPNet.
Sure. Yeah, my kind of introduction is very quick. I just want to kind of let you know that the what kind of a ESPNet is now covering and what we are now also trying to working on it. So I think the some of you here may know that ESPNet initially the mostly kind of developed for the ASR as a kind of a main the application, but we actually thought that especially sequence to sequence modeling has a quite wide the general the application capability of various the speech the technologies in addition to ASR. So based on the such functionality, ESPNet is now the covering the many speech the application like speech brain. Then I would not kind of the quickly go through. I even do not go through any of the applications, but I just want to mention that the many of the techniques we usually also are the published with the paper. So TTS, the TTS2 speech enhancement, the spoken language understanding, speech translation, and so on. If you guys are interested in the ESPNet functionalities, please also check some of the papers that I listed here. Oh, by the way, we also started to the cover the music. I guess speech brain also may have such kind of activities, but yeah, that's the many people are quite interested in this direction as well. So we should definitely cover that the function. And again similar to the speech brain as well, but ESPNet actually cares about the integration. So initially, the why we started the TTS, actually we have a project to the make a ASR and TCS jointly training with the cycle consistency training. So this is actually one reason that we started to build the TTS. So ESPNet TTS is actually implemented toward the integration with ASR. And the same for speech enhancement and so on. And we are always kind of caring about all to be back probable, so that the possibly everything can be the optimized. That is kind of the cares that we are doing. And the ESPNet also cares about, try to compete with the big companies. So I still remember that we started to use a BLSTM, and then the Aachen had a very good number in the BLSTM, and we tried to compete. And then Google made a spec augment, which has a kind of way better. But with the spec augment and transformer, ESPNet once kind of reaching to the Google performance. And then Google guys actually proposed conformer, and further they are actually the advanced. And then recently eBranch former finally also reaching out to their numbers. And the SSL web scale model, we always try to kind of compete the big companies. I think T2M may complain that we should not spend so much time for the libre speech business. That's for sure. But one part we should do some business, one part we should do the other business. That is my kind of style. And then that's actually related to what now we are doing. So the speech foundation models are important areas in our field. Self-supervised model, the web scale supervised large models, decoder-only models. Now the many the big companies are kind of leading to providing a very cool speech foundation models. That's a very exciting areas. And one thing is definitely to use these kind of foundation models. And the other side, we should also try to follow these kind of approaches by reproducing them. So this is actually one of our group's recent focus, and many of the effort on the building large speech the foundation models are conducted. But this is probably the effort that the community can also do it across the toolkit, which we also had a discussion in the last time, the self-supervised learning, the workshop in the ICAST. So yeah, basically that's it. We have a big goal, and which conversational AI or whatever that we want to reach, and many of the techniques are getting matured, but still they are not good enough to making it to be the human level or superhuman level, other entire the conversation. But the hope the people here to gather our kind of experience, knowledge, and the wisdom to tackle some of our the ultimate research goal. Yeah, that is from me. Thank you.
Thank you very much, Shinji. So is there any question from the audience for Shinji? We will have a whole big discussion afterwards, but if there's a quick question we can get it. If not,
you can write in the chat, right? Maybe.
Yes.
So, well, let me thank you, Shinji, for
Sure.
for participating here. Let me say that ESPNet is actually a source of inspiration for SpeechBrain, definitely, because we share more or less the same value, right? So definitely is a source of inspiration in terms of especially in terms of how many models you have is very very good, and also the performance that you can reach really is impressive. So we actually consider ESPNet like something a toolkit that is definitely our source of inspiration. Okay, so
cool.
All right.
So, but actually, SpeechBrain got inspired by another toolkit, which was Kaldi, right? Kaldi, we inherited many concepts from Kaldi, including, for instance, the the recipe concept, which I think was invented by Kaldi and is very convenient. So it's my great pleasure to introduce Povey, who is very famous in the community for many contributors, including, of course, Kaldi, and now K2. So maybe Dan, the stage is yours and you can present your project.
Sure. So I'm just reusing some slides from our tutorial, although I'm going to zoom through them at lightning speed, or maybe just skip most of them. Sorry. So our next gen Kaldi is, people colloquially call it K2, but it's several different projects, including Icefall, which is like the recipes, Lotsi, which is a Python package for dealing with ASR training data, K2, which is a bunch of algorithms in like C++, and Sherpa, which is our relatively new deployment framework. Slideshow is what I'm looking for. Yeah. And we're mainly, the target users we have in mind is mainly companies who want to build their own ASR infrastructure, and people who want to deploy systems of some kind. We're not particularly aiming at beginners or academic users. We care mostly about deployability. The bits of our tutorial that I excerpted for this is, we have a few things showing what the Icefall scripts look like, just to give you an idea. I can mention our latest zip format thing and mention the existence of Sherpa. So Icefall is just a simple Python repo that has a small library and several dependencies. It depends on K2 and Lotsi. And if you go into like one of the recipes, WeNet speech, for example, it's got some like data prep code that's shared, I think, in local, and then it has several different specific recipes. Like our latest one is the zip former. I'll go into that later. And in the individual recipe directory, mostly it's soft links, these ASR data module.py, though, because those are shared with other recipes, they're soft links. But you know, it's got a module.py like many PyTorch recipes have. And that's like an RNNT model. We're mostly focusing on RNNT because it's pretty convenient for inference. When I say RNNT, I mean it's a transducer. It's not like an RNN. It is actually a highly modified conformer, which we were calling a zip former. I'm not really going to go through this, and that you can just see the kinds of content that there is here. This is all about Lotsi. Our modeling code, we're avoiding having too many config layers. We're just it's mostly pretty simple PyTorch looking code. Oh, this is just some wrapper code that gets the model for you. We have a different optimizer. It's like Adam, but it tries to be invariant to the scales of different tensors. Like learning rate is proportional to how big each tensor is. The training loop is like a normal PyTorch training loop, except it has a few things about mixed precision and a few other issues. We recently introduced this thing called zip former, which is it's a highly modified conformer. This is our overall architecture. This just shows what an RNNT looks like, with a decoder, an encoder, a joiner. It's a stateless RNNT, so the decoder only sees the last two symbols. So it's not much of a language model. And we're just replacing the encoder from a conformer to a zip former. But it has a unit-like structure where in the middle of the network, it operates at a slower learning rate, but it has more, a higher embedding dim. This is another picture showing the same thing. Just a few architectural differences include learn bypass, more modules per layer. This is mostly so we can reuse attention weights. Another picture showing the same thing. This non-limit attention module is a bit inspired by some of Shinji's branch former stuff. Different normalization layer. changes to dropout. We use kind of skinny self-attention. It turns out that you can use much smaller dimension for the queries and keys and values than people normally do, and it still works the same, or even a little bit better. Some changes to the, we have a new activation we call swoosh. It looks a little bit like swish or double swish, except slightly rotated by several degrees, so that on the left it doesn't approach 0. Different learning rate scheduler, something called, this is inspired by something in Kaldi, this balancer. It kind of prevents dead neurons and various other like badnesses that can happen. This is some results. A lot of people had trouble reproducing the conformer, though I saw you guys mention that in SpeechBrain you have 2.0. I think we managed to get a bit better than branch former. I don't know if eBranch former is much better than that. Plus, this is rather faster for. It should be faster for inference at least. Ablation. We managed to get 1.66 on LibriSpeech by training on a bunch of other data, including GigaSpeech and Common Voice. And this, so it's got word error rate similar to those big models, or at least in the same ballpark, but it's a very reasonable size model, which is nice. Similar, like a multi-Chinese system, it's working quite well. This is so let me just flip real quick through Fang Jun's presentation on Sherpa. This is the inference framework. We have I'll just zip through this and you can get some general sense of what he's talking about. So basically this is this lets you compile a fairly minimal inference setup. It compiles to like C and C++, and then you can access it through various languages. Look, language bindings include C, C++, Python, and he's added all kinds of languages. So this all goes via Onyx, but then sometimes we export to like NCNN's framework. He's written several different versions of the deployment framework, like Sherpa Onyx, Sherpa NCNN. They're all for like different inference engines. Okay, yeah. So I'm not going to go through all of this. This is just to give you some idea. He's done a lot of work on this. And I think people are finding it quite useful. It supports streaming, which is nice. It's mostly just, I think mostly this is assuming you're going to do RNNT greedy search, but I think that's not the only thing that's supported. I think it might be supporting some kind of rescoring. I'm not 100% sure about that. Fang Jun is the one who really knows about this. Okay, so maybe that's it from me. Yeah, I think that's it.
Thank you very much, Dan. Great.
And also because it's very late there, I know.
Yeah.
So, okay, is there any questions for Dan from the audience? One quick question. We will have a panel discussion afterwards.
I have a very quick question, right? So it looks like, there is a question from the audience, right? Maybe.
Oh, the slide deck.
Okay.
Let me. Someone was asking that somewhere else. Okay, listen. Check the check the. I'll ask my guys tomorrow if it's okay if we upload this, and we'll put it on, let's say, the Sherpa GitHub or something. I'll try to ensure that happens.
Okay. So then it looks like all the models like K2, ESPNet, or SpeechBrain with LibreSpeech, in one way or another, we reach 1.6 on LibreSpeech.
Cool.
Do you think that is like the best performance we can achieve, and what, or there's still room for improvement
But
for
presumably
this?
there has to be some kind of limit. Although maybe we'll go better than that. I think I've seen a number like 1% absolute from one of those big models, or am I imagining things? Like one of those
maybe it was
models.
Nemo, right? I don't remember. I think Nemo had, with a huge model, they have very good performance. I don't remember exactly.
I see. I mean, I suppose you can't really compare across different sizes. The size of the training data is probably the biggest thing.
What do you think? You think like we have to change the benchmark, like switch to something else to have more reliable evaluation?
I mean, I think so. Like, it turns out in LibreSpeech, there's some overlap between the test set and training set in terms of books. So, I'm not some kind of oracle. I don't know that I could say what we should be using.
Okay.
Okay, good.
Yeah, so maybe we can move forward with the presentation. Next up, we have Brian McFee, who's the leader of the project Librosa that probably most of us has used at one point in our Python careers. He's currently an assistant professor of music technology and data science at NYU. Works in the intersection of machine learning and audio analysis, and he's an active open source developer and principal maintainer of the Librosa package. So with that, I leave the floor to you, Brian. Thanks a lot for accepting our invitation.
Right, thanks. Good to be here. You can hear me okay?
Yep.
Yes.
Never hurts to double check. Okay, so I'm going to try and keep this pretty quick and high level, and if you want details, just ask away in the chat or later on. So just getting into it very quickly, I know a lot of people have used Librosa, but I always like to make it very clear what it's intended to do and what it's not intended to do. And the way that I think of it is as tools that simplify working with audio data in Python, and specifically in sort of the SciPy stack, NumPy, SciPy, Matplotlib, that kind of universe that probably we're all living in anyway. And this project, I started with a bunch of other people over 10 years ago now. I can feel my face melting into the floor as I say this. But it's been in active development since 2012. And for the people that were around in 2012 that might remember what audio-based research looked like, there was a lot of MATLAB code and a lot of like custom scripts, and various people would implement things in subtly different ways. And you could never really be sure that you're comparing apples to apples. So the main goal that I wanted for this project was to sort of standardize and have an easy to use reference implementation that everybody could agree on when working in Python with machine learning applications. In my home field of music information retrieval, that was very useful, but we kind of branched out and sort of touch on other audio application domains at this point. So we early on drew a pretty clear boundary between things that had statistical dependencies and things that didn't. So what Librosa tries to do is all the non-statistical things. We assume that TensorFlow, Torch, Scikit-learn, whoever is going to handle the machine learning aspects for us. And we're going to provide building blocks for audio processing, feature extraction, higher level analysis, display, sonification, things like that. So that's basically the scope. We do about one, what I would call a major point release every year. Right now we're on 0.10 and just put out the most recent minor revision, I don't know, last week, maybe the week before. Kind of a blur for me. But it's fairly stable and mature at this point. We have over 100 contributing authors, but most of them are kind of drive-by. There's like a relatively small core of people that work on most of what you see in the package. So hopefully that kind of sets the scope. To give you a quick overview of what the package looks like if you haven't dug into it. I kind of break this into 4 categories of submodules. So at the top, we have sort of the general purpose things that almost anyone is likely to encounter. So this is like basic signal processing methods, unit conversions, feature extractors, matplotlib hooks, a little bit of sequence decoding, things like dynamic time warping or Viterbi decoding in various flavors, that sort of thing, all lives in general purpose. We have some music-related things that are just useful for me and other people, so I put them in there. So things like onset detection, beat tracking, segmentation, stuff like that. We have a few sort of effects, signal decomposition type methods that are not as an end of themselves, but as building blocks for other things. So if you think, oh, I want to do, let's say, chord estimation, maybe it's helpful to remove transients and percussive elements and things like that. So you have a harmonic percussive source separator built in, and then you can pull out just the harmonic content and analyze that without having to worry about transients and stuff. Those, some people use, some people don't. And then we have a bunch of helper functions that almost nobody really knows about, but especially the utils module, if you've never looked into it, there's a ton of very useful general purpose stuff in there. So you have all of that stuff. And this is all pretty well documented, I think. So that's the package overview. I'm just going to spend a minute talking about kind of the higher level design principles and goals of the project and sort of the flavor that it has. So high level, the project is meant to be function oriented. So think NumPy and not class oriented like say scikit-learn. What this means is that everything in Librosa, with a few very small exceptions that exist for good reasons, you have functions where the entire API is specified up front. You have one entry point, one exit point. You don't have to maintain a bunch of state in your head. You don't have to learn object hierarchies, that kind of thing. So when you're learning the package, if you already know a little bit of NumPy and can work with SciPy, it should feel pretty familiar and pretty easy to use. We spent a ton of time trying to get the default parameterizations for everything to be sort of internally consistent and sort of good enough across the board. They're not going to be perfect for every application, but they're usually pretty close to a good starting point. So this is things like window sizes, hop lengths, sampling rates, et cetera, et cetera. That is all sort of standardized. This is a major headache for me in MATLAB land 10 years ago, and I'm glad it's not a headache anymore. Everything is pretty thoroughly documented. We have tons of examples, and the source code is meant to be readable. So part of my goal here is to make a tool that students can pick up and learn to use and then learn how it works. And then if they want to make something better, faster, more specific, they have a starting point. And this also gives you kind of a good reference implementation to start from if you want to build something else. And the last point is, I think, the major one that we need to keep in mind, especially when talking about the latest research, is that the package is not meant to be like the latest model checkpoints for task X. That's not what it's about. It's meant to be simple, stable building blocks that you can use to quickly develop and prototype bigger systems. So think Lego, not, I don't know, a Corvette or whatever. So I think I'm going to stop here. I'm already over time, but yeah, hit me with questions later on. Thanks.
Thank you, Brian. It's a lot. So is there any maybe one very quick question? Otherwise, we really need to move forward. If not, maybe Tituan, you can introduce.
Yep. Sure. Right. So we already presented, I think, 3 great tools that have been out there for quite a long time. And now it's my pleasure to introduce Sanchit Gandhi from HuggingFace. He's an ML engineer at HuggingFace, and he is also responsible, well, he leads the open source audio team and maintains the audio models in the Transformers library that we are using in SpeechBrain, for instance, with the goal of making state-of-the-art speech recognition models more accessible to the community. His interests in research lie in robust generalizable speech recognition. And prior to working at HuggingFace, he completed his master's degree from the University of Cambridge. So Sanchit, if you want to show your slides or a small presentation, your turn.
Perfect. Thanks very much, Tituan. Good evening, good afternoon, good morning, everyone from wherever you're based. In the next 5 minutes, I'm just going to give a very high-level overview of what HuggingFace has to offer, and then what HuggingFace has to offer specifically for speech. So our motto at HuggingFace is that we're the AI community building the future, and that means that we're out on a mission to democratize good machine learning. And we'll now go through what that means for the domain of speech. So HuggingFace can really be broken down into 3 big paradigms. So models, which is modeling code. You might have come across the Transformers library and other new libraries that optimize for the Transformers library. This is a collection of state-of-the-art models that are deemed of interest to the research and industry communities that we aim to reduce the barrier of entry to and make easy for anyone to use. Spaces, which are essentially a form of demo to showcase these models and have an easy way of interacting with them and engage and gauge their capabilities. And finally, datasets. So datasets is very tied to our datasets library, but provides an easy way of loading all the datasets that you need to train and infer with the state-of-the-art models. So one of the biggest entry points to HuggingFace is using the HuggingFace Transformers libraries for many of the common machine learning tasks. And most popular probably for HuggingFace is the NLP domain, but HuggingFace Transformers also offers support for vision, audio, and diffusion. And by support, we mean the HuggingFace Transformers library accommodates the most popular state-of-the-art models in all of these domains. And what it means for a model to be in the HuggingFace Transformers library is that there's an extremely easy interface and API to use that is consistent not only across models within the domain, but also consistent across domains. If you know how to use the library for NLP, it's also very easy to port that to using it for vision, audio, diffusion. It's very consistent across these tasks. So it serves as a way of having an easy entry point through, say, NLP and, say, text generation, and you can easily transfer that to working with ASR, TTS, or audio classification, any audio task. So the main, the center point of HuggingFace is the HuggingFace Hub. And the HuggingFace Hub is, it's a web-based platform where models, datasets, and spaces, which are the demos, are all hosted. And the HuggingFace Hub not only hosts the weights for all of these models and all the data for all of the data sets, but it also pairs them with what are model cards or README files. So in the case that we have Wave2Vec2, which was previously state-of-the-art model for speech recognition, and it's indexed on the HuggingFace Hub, so you can go and you can search for a model. It's tagged as being a model that is used for automatic speech recognition. It's in the PyTorch library, TensorFlow library, and we can find some evaluation results for the LibreSpeech dataset. So if you were to go on the HuggingFace Hub and land on this Wave2Vec2 page, you could scroll through this README and get a quick idea of how the model works and what it's used for. Over here on the right, we also have an inference API, so you can actually record yourself saying a few words and try out the model extremely quickly without using any code, just to gauge the feasibility of this model for your needs. So if you go on the HuggingFace Hub and you select this Wave2Vec2 model, it's only a 3-line API to then use this in any kind of inference situation. So you can import the pipeline class, which is the highest level abstraction in the Transformers library. You specify the task, which in this case is automatic speech recognition, and the model checkpoint, which was the model ID on the hub, in this case, Facebook Wave2Vec2 base 960 hours. All you have to do is then pass the string for the audio file you want to transcribe, and you'll be returned the text transcription. And so it's this really 3-line API that is the consistent API that I mentioned across models and also domains within the HuggingFace ecosystem. So if you can write 3 lines of Python code in this simplistic way, you can do all the machine learning inference that is going on right now. If you wanted to swap out your Wave2Vec2 model for a different model, say the Whisper model, encoder-decoder based, you could do exactly the same process and go to the hub, pick out the Whisper model, have a look through the README, gauge how the model works and whether it could be useful for your purposes. And all the API requires you to do is swap out that model ID from Wave2Vec2 to Whisper, and you can run your code in exactly the same way. So in this regard, it's extremely consistent between models and also tasks. I mentioned that HuggingFace was kind of broken down into 3 areas of models, datasets, and demos. We also have many of the most popular datasets for speech recognition hosted on the hub, one of them being LibriSpeech ASR. The nice thing about the datasets on the hub is that they also come with a dataset viewer or dataset preview. So one of the largest barriers to entry to using audio data is the fact that it's extremely large and it's quite fiddly to actually listen to or get an understanding for what the data is actually like. So you can head to the HuggingFace hub and you can search through and filter various datasets and actually listen to them in real time. You can scroll through hundreds of samples from different splits, different subsets, listen to the audio samples, have a look at the transcriptions, and just view the form that the data would take if you were to commit to downloading it. The nice thing about the HuggingFace API is that it's very extensible to using it with any of the datasets on the hub. So in this case, we simply load the LibriSpeech dataset and we pass it as an iterator through the pipeline object that we just defined. The HuggingFace hub, though, isn't just restricted to models that are in the HuggingFace libraries in the HuggingFace ecosystem. There are plenty of models that belong to other libraries, and I picked up this one from SpeechRange, just a TTS model. And the interface for interacting and engaging with these models on the hub is exactly the same as it is for models in the Transformers library. So here we have a README card that we could read through and understand how the model works. We also have hosted inference API, so we could write a few words and hear the model synthesize the speech, and also instructions for how to use this model in SpeechRange. So the HuggingFace hub isn't limited to just models in the HuggingFace library. It's more general in this regard, that it really is a place to host all machine learning models. In terms of where our libraries live, they're all GitHub based. This means they're fully transparent, and also we encourage the community to collaborate and contribute features and integrations that they deem interesting. Briefly, the Transforms design philosophy is a single file policy. So what that means is all the modeling code for, in this case, Wave2Vec2, is contained within a single Python file. There are no abstractions and there's no inheritance, meaning all the code that you need to run the Wave2Vec2 model is, in this case, about 1,500 lines of code. So if you wanted to build on top of Wave2Vec2, you could go to this file, copy and paste it all into a different file, make some changes depending on what research or application you required, and the model will work out of the box in the same way that it does in the Transformers library. And in this way, in this regard, the models are extremely composable and can be modified with extreme ease. So my question to you really is, what features would you like to see in the Transformers library? We're constantly building and developing it and trying to really match it to the needs of the academic and industry communities. So if you have an idea, I'd encourage you to raise your hand, come and join us on GitHub. We can discuss it on an issue or a pull request, talk through it together and have a contribution to the library. In this regard, it's extremely community driven, and it's us together as a community that are working to push this library forward.
All right. Thank you very much, Sanchit, for the great presentation. Is there any quick questions from the audience? If not, we really have to move forward because we're kind of running out of time. Yeah.
So yeah, I think there is another important library that is like part or dependencies of many toolkits and projects, which is Torchaudio. And for that, we have the pleasure to have here Zhaoheng Ni, who is a research scientist in the PyTorch audio team at Meta. So Zhaoheng, please share your presentation.
Yeah, thanks for having me. Can you see the slides?
Yes.
Yep.
Okay, great. So yeah, it's my honor to be here to introduce Torchaudio, the official audio library under PyTorch. And my name is Zhaoheng Ni. I'm a research scientist at Meta. So today I will first briefly introduce what is Torchaudio and talk about the main components of the library, like I/O, feature extraction, pipelines, and recipes. So as we know, Torchaudio is the official library of PyTorch. It is purely open source, so you can fetch the code on GitHub. We also have a very detailed documentation on PyTorch websites. And the goal of the Torchaudio is to accelerate the research in audio domain with PyTorch. And we provide building blocks for audio applications such as I/O, feature instructions, models, datasets, and training recipes. We have 4 people working on Torchaudio project at Meta. So it's really a small team. And we very encourage open source community to contribute to Torchaudio by either opening an issue or contributing the features. Yeah. So let's talk about the audio I/O. I think Torchaudio.load is the most used feature for the open source users. It is pretty easy to use and very simple. Of course, it has its own limits. For example, it can only accept audio formats, and it can only accept file names and file objects. So recently, we developed some new features, which is called Torchaudio.io. So this new I/O module can load not only like audio files, but also like images and videos, so that users can develop the multimodality modeling by using Torchaudio. And here is the basic usage. So you can initialize a stream reader object with the source. The source can be the audio format or the video format. Yeah. We also support streaming use case. So if you want to build a streaming ASR, you can use this stream reader object. Yeah. Another component is the feature extraction. So at the beginning, Torchaudio wants to, add features that are consistent with Kaldi or Librosa. For example, the SDFT feature or MFCC. And later on, we also want to include other features such as the spec augmentation for ASR that is described in this slide. And also we receive other features such as such as the L filter feature contributed by an open source researcher called Qingyun, who is doing a PhD at Queen's Mary University. And we also have like the image source method for multi-channel room impulse response simulation. Yeah. So I think compared to NumPy or SciPy feature extraction, the advantage of Torchaudio is that first we support differentiability thanks to PyTorch, and we also support GPU device that can accelerate your training speed, and we also support Torch script, which means you can deploy this feature to production. Yeah. Next thing I want to talk about is the pipelines. It's pretty similar to HuggingFace pipeline. Basically, you have a pre-trained model and some preprocessing units that you can give this pipeline a waveform, and then it will generate the result for you. So here we have actually an ASR example that is called informal RNT-based library speech pipeline. So this pipeline will generate the transcription by given a view form. Yeah. Okay, so we also provide a bunch of recipes actually that covers self-supervised learning, ASR, audio-visual ASR, and multi-channel speech enhancement, source separation, and text-to-speech. As you can see, some of the recipes are not state-of-the-art, right? For example, we have Conftasonite for source separation, but in SpeechBrain, it has Subformer, and the ESPNet has TF Grade Night that can both achieve about 20 dB performance. But here, our goal is to provide some educational recipes to the users so that they have a basic understanding of the task and how to tackle this task using the PyTorch models. And if users want to, build the state-of-the-art models, they can either choose SpeechBrain or ESPNet or the IceFall, which is the recipe repository of K2. Yeah, I think that's it. Here is the code of Torchaudio. And we also have a ICASP publication. Feel free to check out the documentations and the file issues and the feature request. Yeah, thank you.
All right. So questions? If not, maybe we can just go directly to the panel, right? Sam, maybe you can start with some questions and we do a round of comments. We can maybe start first with our guest and then later with someone from SpeechBrain.
Yes, yeah, I guess at this point we can start the discussion. So maybe like let me do it like this. Is there any, so like after hearing all these great presentations, is there any like burning questions from the audience? Maybe let me first do that. If not,
yeah, let's do that. The audience is gonna think about questions. Meanwhile, we do some kind of questions which we have prepared beforehand.
Yeah, exactly. So yeah, while you guys think about questions, maybe I can ask. So I mean, you listen to, like, it seems like there's like an ecosystem of these open source softwares, right? And like, how do you see your toolkit like being alive in this like environment? Like, what is like the differentiating aspect? Do you think that moves the like, what is like your the thing that you value most in like a toolkit? Just to start things off, like yeah. So anybody who wants to reply?
Well, for us, I think it's deployable ASR, that's efficient.
I see.
We don't have as wide a variety of things that we support as you guys.
I see. Deployable, real time.
Yeah.
In ESPNet, reproducibility and try to kind of providing the benchmark platform for various tasks, and generally the performance would be state of the art or anyway publishable result. So the to kind of do some research and starting from something that we are always caring about it.
I see.
In the case of HuggingFace, it's by far the low barrier to entry and the consistency across models and tasks. Having both, well, there are various degrees to which you can interact with the library. The most highest level of abstraction is just 3 lines of code, or you can copy and paste those 1,500 lines of code and develop on top of that. So you have complete granularity over how much you want to interact with the library, and we kind of cater to that full spectrum.
I see.
Yeah, I think broadly the same for us, maybe with a little bit more of a skew towards kind of cracking things apart and taking a look at how they work. In research, we tend to focus a lot on the people pushing the needle and then forget that there's like 95% of people that just need something that kind of works and they don't want to have to think too hard about it. And I think that's where a lot of the Librosa usage comes up. So I want to help those people kind of get up to speed and get a little better.
Right.
So
Yeah.
in terms of Torchaudio, I think we want to provide like most commonly used components, such as the RNN transducer loss function, or like the audio loading, video loading stuff. Yeah.
Well, on our side, SpeechBrain, we value a lot the ease of use, right? We would like to be as inclusive as possible, and make sure that even practitioner or the students can like at least do something within a reasonable amount of time without necessarily being 100% experts. That's what we are trying to do.
I think even if we had the same goals, it would be fine to have multiple different toolkits, just because there'd be too much, there'd be too much conflict. Like so many people can't work on the same toolkit. Or
Yeah.
Right.
You can't design things with that many people. Like the community is too big to have just one center where people do things.
Right. With that, maybe like I can ask this hopefully related question. What do you think like are the challenges of running a big like open source project like this are like with like for instance in SpeechBrain you have like more than 100 people. I don't know, I guess size differ from project to project, but like, yeah, in general, you can answer however you want.
I think it's like personal and financial, because like each of these things, the people have maybe slightly different personal and professional reasons why they're doing it and how they're funding it. Like for Shinji, I assume it's kind of an outgrowth of his academic career, right? Whereas for me, it's right now it's not really academic. It's funded by Xiaomi, and it's kind of geared towards their needs of that's partly why we're focused on deployable ASR. We're not so much on publishing.
I think in terms of how you can grow a library, I don't think there's necessarily an upper bound of how many people can contribute to it. I think if you define the scope of the library and you define very clearly what the design is, then I don't see a reason why you couldn't have everyone in the community contributing to the same library. I think like it's almost like having a game. Like if you define the rules at the start and everyone plays by those rules, then you can have, say, like football, which is played all over the world. And so I think it's
but I assume HuggingFace ultimately has business reasons behind this whole thing too, right? Like I don't know what the business model is, but I assume it ultimately has one.
Well, I think like even purely from the open source perspective, there's I think like I don't see a reason why. Like I think a library can be inclusive and large enough that you could.
It can be, but in practice, would it be? Because I assume you guys get paid a salary, right? And someone must have a reason why they want to pay you a salary to do this. And all of us get paid somehow. I think most of us do anyway. Maybe not all of us.
Well, you get compensated for working full time on the library, but it's no different to like anyone in the community also doing that as well. Like there are business intentions, but I don't think that necessarily changes. Well, like the scope of the library can either be defined kind of from like the end user perspective or from the business use case, and I don't think the two.
Well, listen, probably Michelangelo told himself that he was doing all of that artwork just because he was passionate about art, but he was also being paid by the Medici family, right? So I don't like those can both be true. Or whoever was paying him, I don't know if it was the Medicis, but it was someone rich.
Yeah. Right. I mean, there's like publishing. I mean, putting your code in like a high visibility, like having a high visibility toolkit also helps like the visibility of your research also, right? Like maybe not immediately getting funded, but you can get more citations, for instance. If you
yeah, well the academic model is, you know, it's all based on citations and stuff. Like academics are incentivized to want to do that.
Yeah. Also, it's a good educational opportunity for people to touching to the large scale software, which can be, you know, used for their, you know, future career. It can be academia, it can be industry, but that can also be a good motivation for the people to, especially young students, to work on this the open source. That I observe. Yeah.
Yeah, I think part of that is also the challenge of maintaining an open source project in the space, because, you know, this is common to every large open source project. Getting people to contribute is hard, and getting to stick around and contribute more and get more engaged is hard. In audio specifically, that becomes compounded by just the difficulty of working with audio in the first place, right? The people that become really good signal processing engineers are not necessarily the best software engineers, and vice versa. So you start to winnow down the field of people who could meaningfully contribute, and it gets pretty difficult to maintain these things in the long run. So that's the challenge that I've had. I don't know if anyone has answers, but that's where I'm at.
Yeah, I agree.
I think in all cases, there's one or two or several people who have some kind of, you know, who've decided to do this for the long term. For whatever reason, whether it's idealistic or professional or whatever. Because these projects, they don't like automatically stay alive, right? Unless there's someone you know, being the overall maintainer and maybe even paying for a team or ensuring that people get funding, these things wouldn't naturally stay alive. Like, let's suppose HuggingFace went out of business. I doubt that HuggingFace would have much of a future. And it's probably the same if any of the leaders, you know, of the individual projects were to die or something.
That's
Yeah,
fact.
that's true. Yeah, that's true, actually. Yeah, I mean, that's a big problem, right? So how can our projects survive to us, right? I have no solution to that because, you know.
I think they don't have
Maybe
necessary.
they don't need to. Like the things that you come up with can often be just more easily replicated outside of the project, and someone will always come up with something better and more elegant after you've figured out, you've solved the problems, or yeah.
This one?
No, I mean, I totally agree. The thing is, like, if we stop and the project disappears, someone else will just do it in the end, right? I guess it has been the same since the beginning of open source code and people sharing project and blocks. It's just that now it's much more widespread across the community. But I guess it's not much, oh, we can make sure that the project will remain, rather than, as long as we are interested in doing it, oh, can we make sure that we have the resources to do what we want to do, which is more problematic in my opinion, because it's clearly not there. Like, founding open source is like still an open question, just like the fact that sources are open.
So please, leaders, do not all travel in the same plane to a conference. Okay, that's gonna be hard, fortunately. So Sam, I think there is a question from the audience, right?
Yeah, there is a like a career wise type of question. So there's a undergrad in the audience, basically is asking, what's a good path to ace in this field, as I have learned ASR from Kaldi and basics of signals from Librosa? First question, heading the industry is better after undergrad? Or doing MS, PhD, join a research team with becoming research engineering scientist as the goal? Yeah.
I think these days it makes less of a difference whether you have an actual PhD. I think you can get to the top level of this without having the formal qualification as long as you have the right mindset. That's my personal opinion. But maybe some of the academics will disagree.
Shinji?
I just don't like encouraging people by default to go for a PhD because I feel like it's not good from a life cycle perspective, because if everyone's encouraged to get a PhD and they're in education basically till they're 30, a lot of people just aren't able to have a family before they are no longer of reproductive age. You know what I mean? And ultimately, it's the biological foundation of all of this that it is required for anything to happen. So if you make that untenable, you make the whole civilization untenable.
Well, now, people can, in average, live 80 years. So
you can live 80 years, but can you have children at 80? The answer to that is no.
Yeah, still the children, after children, the mature, we have the dozen years to work. Whether going to the PhD or not is a difficult question, but I usually mention that the going to the PhD may have some possibly more opportunities in terms of for example the being in the more for the academic side. So in any career is fine, but if you are thinking about some kind of opportunities for the mentoring, educating some people and so on, as also career paths, please also consider PhD.
I agree with Shinji. I think it's like potentially two different paths that could get you to a similar point. Like if you take the PhD route, it's likely that your focus is going to be on papers and citations. That's the metric in the academic world. If you go into a more industry role, there might be impact through usage, or there'll be different metrics. So they're not necessarily apples and apples. There could be different routes to get to the same point, and it's potentially weighing up which of those appeals more to you. I also think that potentially in a PhD environment, you're guaranteed to grow and learn, and if you go into industry, that might be something that is less of a, like, I think like looking for a growth opportunity in a place that you can develop is something that you would have to kind of litmus test and find to yourself if you go into industry, and ensure that's the right environment for you to get to where you want to be. The PhD is more defined in that regard.
It is quite possible to do a PhD and not really develop.
It's true with anything, in the sense that you can work for it. So I mean, like, but I think it's potentially more clear and more worth. Like if you join, if you join Shinji for a PhD, I'm sure at the start he's got a plan for you after 4 or 5 years.
Hopefully.
By the way, I have to leave now, so thank you everyone.
Bye, Shinji. Nice to see you.
Bye.
Bye.
Bye. So I think there is an interesting question from Adele. Right? Maybe you can do that, Sam, right?
Yeah, Adele can. Yeah, you can ask Adele.
Yep. Hi everyone. I just have one question about like the current trend in the community about like scaling larger and larger models, especially like in for ASR. I know that there's still a need like for having like small footprint models, but a lot of people and the community is asking for like model like Whisper and so on. And what do you think like about that regarding like open source? Do you think like it's manageable? And especially like about human and hardware resources, do you think like we can keep up with that? And yeah, that's my question.
I've seen recently a paper where someone had a graph of like maybe training time versus performance, and it was about pushing the line down, so that with more training time and more data you can always get better performance. But if you plot it on a line, there is some kind of line, and I think it's all about pushing it down. So My feeling is that we give too much attention to these huge models like, you know, Watanabe and Whisper, because it just means that someone had a lot of money and they were able to train a model. It's just one data point. And, you know, maybe you could have trained the same model more cheaply over here, and you could have done all that development at a different point of that graph. Now, I'm not saying that you necessarily could have, because sometimes there's size-dependent effects, but I don't think we should get taken in by all the hype around these huge models. Like sometimes it's just that someone spent a lot of money to train a really big one.
I think also though, like if that data point is there, then there's no reason why people shouldn't exploit that as well. Like if there's a huge barrier to training these models and putting another data point on.
That and to be able to use that, but I just don't think it's healthy if people think that the only way to do meaningful work is to train a huge model. Because there are other ways to do meaningful work, or even to fine-tune a huge model, because there are reasonable ways to train a, you know, medium-sized model, and sometimes for a particular application it's the best thing to do.
Yeah, the limiting resource there is the data, right? It's not the software or the model or anything like that. And kind of the default way that machine learning works is exchanging data for knowledge or information or structure, however you want to think about it. And if somebody's put in the work to collect a huge data set and train a model that extracts information in a useful way, yeah, use it. We don't need to compete with that. We don't need to change it if it generalizes. But if you have a different problem that could be solved with a much smaller data set and a more specific model, go for that too, right? It's not an either or. It's just, you know, it's all trade-offs. I don't think there's really like you don't have to choose between these things, right?
I think it also depends on your end objective. If you want to do fundamental research, if you want to have something that's very elegant, then I think by all means try and get a data point that's closer to the origin, shift that line. But if it's something that you want to get up and running quickly and you're very time or data or money pressured, then using one of these existing checkpoints makes a lot of sense in that regard. And there's huge bodies of work that try and make these models more accessible, even though they're growing larger. There's so many engineering techniques that try and push it the other way. And even though these models get larger, you can quantize them on the fly. You can do dynamic quantization, reduce their footprint, and you can speed up the inference speed. So I think even so far, I think these ASR models are still pretty usable on consumer hardware. If it scales up to LLM size, then that might be a different matter. But currently in the region of billions of parameters, it's doable.
And there was like a pretty interesting paper from Shinji's group, like at ICASP. I don't know if you read, like about training Whisper with academic compute, right? So that's unfortunately Shinji left. Otherwise, he would have said something. But in general, I'm pretty concerned about this trend because, you know, we can be clever, we can be whatever we want, but, you know, the trend is clearly like that, like bigger model, better performance, not just in audio, speech, but in language models as well. So I think the question is like, are we able to follow this trend? I'm not sure. Maybe we could find like some kind of partnership with companies, like a little bit what OpenAI did at some point, right? So, such that we can have more compute even for an academically driven projects, or we can focus more and this is what we are going to do actually on scaling down. Right? Scaling down the technology, making the technology working well, even with with reasonable computing, right? So also, you know, this trend of scaling up, you know, is gonna hit a limit at some point, and you know, even for companies, right? It's like very hard to put in production a model, right, which is very big and, you know, requires 8 GPUs for for doing an inference. So I think there is really room for like scaling down the technology and not just scaling up. That's my point of view.
I think there's reasonably high probability scenarios in the next few years when it might become impossible to produce the current latest chips for a while. So we might be forced to learn to scale things down a little bit. basically if it's not possible to get the best GPUs for a while. Because the supply chain, the manufacturing system for the smallest feature chips, it requires a cooperation of a lot of different countries, right? And if there were to be some kind of trade war between certain major players, it could be shut down.
Right. So there's one question from the audience. Maybe we can continue with that. So they're saying about model size, trying to denoise speech in noise, but have hardware and power constraints, like it's a variable device. Do you think you take a large, well-performing model and try to shrink it, or start with a constrained model and try to achieve the best performance?
I don't think you can really shrink a large model in a very meaningful way. I guess you can do student teacher, depending on the scenario. That can help. But it's still going to be a small model. It's not going to be that. It's going to be closer to the small model performance than the large one.
Right.
Although I slightly question whether you want to train a deep learning model to denoise speech and then put that into ASR, because that doesn't always work. Like ASR doesn't always work well with denoised speech. Because if it's from multi-microphone, that's different. I think sometimes the multi-microphone stuff can help.
Yeah, it sounds like there's also specific constraints around the hardware. I kind of wonder if there are constraints around the data as well that might be helpful. If you know something about the kinds of noise you're likely to encounter, that might push you in one way or the other in answering this question.
Right.
And maybe if there is also another question from actually Adele that was pretty interesting. The one on like cooperation. Do you see it?
If
I can read it if you want.
Yeah, read it.
For Adele, it's you.
Yeah,
it's your question.
yeah. Again, no, I was just asking, like, if tomorrow, like, running competitive open source toolkit was starting to be more and more expensive. Do you think, like, you will change your mind about the idea of merging open source toolkit, human resources, to maybe not just only one academic toolkit, but less than the current landscape of toolkit that we have currently?
I think it's very hard just in terms of human relationships to merge multiple projects like that, because each of these projects, they depend on a set of working relationships between people who often are like physically located close to each other, like the core members of the team, right? And they know each other, they often have for a long time. It's hard to, like, unless there's some change, like let's suppose certain people move groups to be closer together, I think it's hard to do that. And it's not absolutely clear that there would be a lot of benefit from it, because the different toolkits aren't doing exactly the same thing, and we are learning from each other as well.
Yeah, and I think a shallow fusion, right, across toolkits might be very, very bad, right? So if you will like really it's easier to start a new toolkit from scratch than merging two existing toolkits. That's my feeling.
Yeah.
It's a teamwork thing also, right? Like, I mean, people might not be compatible.
Yeah.
So,
it might be good if we were to occasionally just briefly compare notes about interesting things we found lately, or because we do eventually learn things from each other, just because we hear, this group has this good performing model. sometimes you would have picked it up earlier if you had done a sync. I don't know. But of course, we're probably always developing new things that don't pan out. So we might just end up wasting each other's time.
It can also be a case that having integrations between these libraries can be something that, kind of works for the user to some extent, but they're difficult to maintain when libraries diverge. And also,
there's version numbering issues.
And also like with these integrations, they're kind of like that shallow fusion where some things might work, but like if you want to really like fuse these things together on a very deep level, then this is something that's also hard to merge the directions of two libraries together if they're intrinsically different in the design.
Yeah, I might be
IBM. Sorry.
Oh no, go ahead.
Once at IBM, there was 2 toolkits for speech, and the word came down from management that they wanted the groups to work together, and they had all these meetings, but they basically ended up talking past each other and arguing. It was just incompatible personalities. Okay, go on. Sorry.
No, it's all right. I might be kind of an outlier here because the stuff that I work on kind of touches a lot of different things and isn't focused on a specific modeling problem. But the sort of things that I've encountered more often is migrating functionality into or out of a package rather than merging with another package. For example, I used to have code that would do like sample rate conversion, and then better sample rate converters showed up. So I deprecated my implementation and absorbed theirs as like a library dependency. Or maybe I have code for doing some kind of display that gets generalized and then that moves over to Matplotlib or something like that. So I think that kind of piecemeal migration of functionality is more likely to occur than like a package level fusion sort of thing. Because then you can at least maintain API compatibility, even if the actual implementation is moved out from under the user. They don't need to know that.
Yeah. Wait, so what are you using right now for sample rate conversion?
Oh, everything. Soxer is the default. Lib sample rate is supported. SciPy sample rate converters are supported. There's a bunch.
Yeah. I also would like to remark that a bit of competition is healthy, right? Somehow, because for instance, like I don't know, ESPNet is coming with a good model that is beating our models, right? So we have to react somehow and have stay state of the art, right? So the fact that there are like a few toolkits is not necessarily bad for the community. It can be very good. We are forced to stay updated. Imagine if there were only one toolkit, right? In a few years will be really outdated because there was no pressure, no competition, right?
Okay. I have
Maybe
one question.
Zhaoheng, do you have some comments on that?
Yeah, I think if we merge all the toolkits into one, maybe each unit test may take much more time, right, for one pull request. That is impossible to be merged.
Yes.
Okay. I have one question about like the way research and like maybe more pedagogical aspect of like learning to do research. Like with all these toolkits, it became the barrier to entry is like much lower to what it was, I think, 10 years ago when I started. So I kind of, I don't know, came up with the, I would say, I'm going to say indoctrination that I need to implement everything myself, right? And now it's not the case really anymore. Actually, if you try to implement everything yourself, like it's going to take really a long time with these complicated models and everything. What's your take on that? So like a newcomer, or like for a new professor, like if he's kind of like me, who's going to teach these things in a class. So like, what should be the best approach to teach people this stuff or to learn?
I think it's really hard to find the right balance between going too deep or being too shallow, because you can often make this progress in the short term by just linking together things that you find on the internet. And like the person who does the job fastest is probably going to be doing that approach. But in the long term, they won't develop if they never go deep into anything. And it used to be the case that you could learn everything and implement everything from scratch, but it's becoming less and less true, I think.
Yeah.
And I never have to find that balance, because I could always like do everything and just learn all the things, but it's just not feasible anymore. And you've got to, I think kids learn it much sooner these days. They learn when to stop digging, because it would be impossible to dig to the bottom.
By the way, why do you think that is? Why now? Like before, we could just like learn how to like do EM with hidden Markov models, and there you go. Like it was a really good exercise. But now, for some reason, I don't know, like implementing an RNN or like doing backpropagation with like an LSTM is not doesn't cut it anymore. Like why not? What changed? Because I think I have an answer, but like
I'll be kind of glib. I think we don't really know what we're doing in the sense that like EM has pretty good properties. We understand it. Doing some flavor of kind of weighted gradient descent on some kind of RNN transformer, something or other. Is it going to converge, or the weight's going to blow up? That is numerical stability a factor we have to worry about? There's a bunch of stuff that is like way deep in the weeds that we can't expect a student to get in like 1 year of training, right? Where if you're doing EM on a hidden Markov model, yeah, you can expect that. You know where the dragons are, you can dance around, it's fine. But when there's so many kind of unknowns that we sort of sweep under the rug just for the sake of getting results out, it becomes kind of tricky, right? You don't know where to stop. But that's my opinion.
I agree, I think, yeah.
What I do, right, as a professor to my early career students, what I suggest them the first time, implement everything from scratch or stay as low level as possible, because the first time at least you need to understand what is going on. Then when you understand that, when you understood that, you can go higher level and be faster. But the first time, stay low level. That's what I do in my courses, right? So typically I try to, the first time they see a neural network, you have to implement them in NumPy, right? With also the backpropagation part implemented by hands. But then when they move on, they take advantage of automatic differentiation and higher level toolkits. Because otherwise the risk is that, people will have a superficial understanding about what is going on. I realized that many times in my interviews, right? I interviewed so many students, they have many papers, whatever, but they don't know what to do exactly, really. They have like, they use such a black box neural network, such a black box toolkit, and they don't know what they are doing, what is inside this black box. So I think students, they definitely have to go low level, especially in the early part of their career. That's my suggestion. Otherwise, you don't know, really. You don't understand what's going on in the pipeline.
Yeah, I mean, understanding fundamental things definitely help, but to get kind of up to speed in research, sometimes, I mean, like hacking things also can work, like didn't used to be the case. So things change.
It can work, but I think the best things, the cleanest things for students is to stay as low level as possible the first time you implement something. Right?
There's a story about how the philosopher Wittgenstein became a philosopher, that he originally was going to study engineering, and he got interested in this problem of fluid flow, and he started getting deeper and deeper into the mathematics of it. But eventually he got so deep that he got interested in the actual foundations of mathematics. And that eventually took him into philosophy. And he ended up asking questions like, what is the meaning of language and stuff. I mean, he was legit crazy. I think he killed himself in the end. But maybe it shows the danger of trying to go too deep.
Right.
I think with your question regarding like should you do it all from scratch, I also don't think there's necessarily a point in implementing everything from scratch if it already exists, but building on top of that from scratch code is often quite a good exercise. So if you've got something like a transformer, you've got the attention module, can you do something new with that? So you still understand the code, but you see how it's written out, and I think that can kind of marry the two together where you can see you can utilize existing code but build on top of that and still hack around.
Yeah, I mean, doing the exercise helps, but like, yeah, thanks to these toolkits, not going too deep is also okay, can be okay. Like, you don't need to understand sometimes like everything and still, publish papers. I feel.
I think there's also a career aspect to this of making room for yourself to learn stuff, because if let's suppose you want to be promoted at work, that might require that you show some results in the short term, right? So you might be forced to do things that are a little bit quick and dirty.
Right.
Whereas if, let's suppose, you've already had some success, and you decide that instead of maximizing that success by, trying to get a big promotion and make a big noise, you just relax for a bit and learn some stuff. I mean, my point is that the way you handle decisions like that, about whether to get an immediate payout or whether to just coast for a bit, it affects how much career leeway you have to actually learn stuff.
I don't think it's actually that different from how it used to be. This isn't universal, but at least in my training and a lot of other people's groups and labs that I saw, you had the option to implement things from scratch, especially in a classroom. But if you're working in a lab and you're building on the next oldest student's results and trying to extend it, you take their code as a starting point, you modify it. And using an existing implementation is just that, but better, because it's had more eyeballs, more testing, more documentation on it. So I don't see this necessarily as a bad thing, but it takes some discipline to actually understand what you're doing. But it's not that different.
Yeah.
No, my feeling is that the more low level is your knowledge, the higher is the chance to succeed, right? Because otherwise, I don't know, imagine you writing Kaldi without any low-level knowledge about, GMMs or interpreter models, whatever, right? Impossible.
Yeah, I suppose. But let's suppose I had been too obsessed about writing absolutely everything from scratch and had refused to use an existing FFT implementation. Like, I could have been just taken so long that someone else would have done it first.
Yeah,
that's exactly what I mean, right? So definitely, you should know the details about everything, right? As much as possible. Maybe it's not possible at that level, but at least more than what people do these days.
Definitely, you're not gonna do like some crazy butterfly implementation for an FFT, right? Like you're just gonna use Librosa or whatever, like Torchaudio, and you'll be done with it if you're.
Though these days it's easier. Back then it was all in C, and it.
Right.
We use Pocket FFT.
Managed to get a guy, this Rico Malva at Microsoft. He had the copyright that he was able to give us to his own FFT implementation. These days, of course, there's many options.
Right.
Although we probably could have just done it using a for loop, it would have been faster now.
I think as a research student, maybe modifying the existing SOTA recipe is a good way to get familiar with the toolkit, right?
Yeah.
So to take the speaker recognition, for example, if you implement like iVector from scratch, or you modify the current, kappa TDN, which one can make you closer to a new publication? I think maybe kappa TDN should be a better choice for research student, right?
Right. Yeah, I think like we have I think I like this discussion, and it's like I think we agree to agree. Like there's a fine balance I think to strike. But any other questions, Mirko, Adel, from the audience?
I haven't heard much from Mirko, have we? Or am I misunderstanding?
So my point of view?
I don't know, just generally in this discussion.
Yeah, that's what I told you, right? So you have to stay as low level as possible
Okay, sorry,
in the
sorry.
first implementation. That's
I
me.
didn't realize that it was you. Okay, sorry.
Yeah, okay. I don't know if there are questions. Actually, if you okay, maybe yeah, I have a question for you. So more general question. So what do you think about the future of Python? Right? Do you think that Julia at some point will replace Python and we have to start from scratch?
Wait, the question is for who?
For everyone.
For everyone.
Start if you want then.
I just learned about Julia. I was a little bit excited. I thought it was cool. Well, especially how it tries to. I guess I like its dynamic approach to compilation. How it doesn't try to compile everything in advance, but like does it for the platform. Because these days, so much of our problem, so much of our time is spent with version compatibilities and like trying to find compatible versions and trying to compile stuff. And I guess maybe I'm dreaming of some utopia where code is distributed in a different way and is compiled like when it's needed. I mean, we'll never get away from version compatibility completely, but maybe by starting from scratch, we could at least make the problems less.
I don't know. I like Julia. The one-based indexing thing bothers me, but
It
that's
has one-based indexing. I didn't know that.
you can change it, but by default it's one-based, and that bothers me. But
that
it's a
bothers
choice.
me.
It's fine. It's fine.
That's weird that they would do that.
Mathematicians, dude. You know, it's cool. But in terms of the future of Python, I think we're kind of stuck with it for a while. It's got tentacles in everything, but I don't think it's necessarily a bad thing, especially with some of the what's it called? Sort of the web integration that's happening now, where you can have Python runtimes that just live in your browser. That's going to simplify deployment of a lot of the stuff that we do that is built in Python. Yeah, PyScript? That's what I'm thinking of. So, WebAssembly compilation of Python code, having that runtime in the browser, so you don't have to distribute like an Anaconda environment just to get your model set up. You can just click go. That to me is exciting. That seems like the future, at least for the short term.
I think also while we're seeing innovation when it comes to libraries that are built on top of Python, that Python is still going to be like that signals to me that Python is still something that's exciting for people who are developing machine learning frameworks, that you take Python as the base and you build on top of it. So, I mean, like 99, so much usage comes from PyTorch and TensorFlow, but these aren't the only libraries that you can do deep learning in. Like there are other libraries that try to tackle these issues of compilation and try and make these models more efficient with like JAX or other machine learning libraries. So I think for now, I think we'll stick with Python, but maybe it's the PyTorch aspect that might be a bit more fluid at the moment.
Yeah, actually, Julia is like 10 years old, right? A language, right? And still like kind of still Python is still like by far margin the best. So no, I'm not sure what is gonna happen. Like if Julia will take over or will die. So really unsure about that. But for sure will take a lot of time, like switching from Python to something else, because everything is there. Even though Python is not perfect, right? It has many issues, right? For loops, for instance.
I think they need to improve the way the library dependency system works, and the fact that you can only have one installed version of a given library in a given environment. I think that's a real weakness, because you spend so much time. Like, let's suppose you want to run some model. It turns out, oh, the version of PyTorch is wrong, but then there's 10 other packages that are linked to that, and it just takes forever to fix it.
Could that also be fixed with design of the library with reducing the number of dependencies as well? You go for a very sleek library design where
I mean, of course,
Python,
that
PyTorch.
helps, but the fact that in any environment you can only have one version of everything, it's just unnecessary for a lot of things, because often the way you're using another library is you're just calling some function. You're not really maintaining a bunch of state. And there's no reason why you couldn't have two, let's say, packages calling different versions of some sub-package. Like you'd have to figure out a way to specify that and to configure that, but it seems to me that it's the only way to get out of dependency hell. That's partly why I was attracted to Julia. I just had this idea that if instead of viewing libraries as these like compiled blobs, we were to just view them as a collection of code, then you could analyze at the point where you tried to call the code whether everything was okay. Like, let's suppose you import some library, but you only need just some random little function in the library. That function may not have all the dependencies that the library itself has. So it could be that you don't actually need to fail and say, oh, these dependencies don't match, because for the specific uses that you're doing, it doesn't actually matter. Of course, that's dangerous too, because you might get runtime errors that are hard to debug. But I just feel like the current setup is a bit broken, and it's just we spend too much of our time dealing with stupid library dependency problems.
Yeah, I agree. But at the same time, I don't see any clear solution to this problem. Yeah.
Yeah. Well, I don't think people I don't know if there's any language that actually lets you have multiple versions of the same package and like have different things, like somehow refer to them or use different sub-package versions. Because even Linux doesn't let you do that with like named SO, like shared libraries.
Can't you do that with Node?
I
It's been a while since
I'm not good enough. I've never used Node.
I might be totally wrong on that. But it feels like there's a lot of bloat whenever I install anything with Node, and I figured that was why.
So I was interested at one point in the Urbit project, that they were trying to rebuild computing from the very ground up, starting from this very simple virtual machine. And I think the basic unit was like, it's an integer but of an arbitrary length, and then you can construct lists of them, and he somehow builds up computing from this very narrow base, kind of like how mathematicians try to build up math from this very simple set theoretic axioms. I thought it was an interesting alternative approach, because our current computing doesn't really have that narrow base. Like there isn't some common language that's simple, that's just, I don't know even whether it's a good idea always to try to do that, but if we had that kind of language built on a super narrow base, it might solve certain hassles we get into when we're trying to install libraries and stuff. Like if there was just one standard computing model that all computers somehow used. Of course, it wouldn't be optimally efficient, but maybe we're reaching a point where we're spending so much of our time just dealing with version compatibility issues that we could take the hit in efficiency just to have everything simple. I don't know.
All right. So maybe you can switch to another question, right?
Yeah.
There is actually, so it's Vadim Kantorov. I think I gave you voice access. Maybe you can ask your question.
Vadim? I think Aku is asking a question. Right?
Or also Aku, yeah.
Is it me or somebody else? Well, I'll go first.
Yeah.
I'll just take the stage. Thanks.
Yeah, just go ahead.
So my question was, do you think there are some, or do you have in mind some kind of good research or engineering practices that you would like to see get adopted by the speech tech community? Because my opinion is that like these open source toolkits have maybe a chance to use their influence to kind of promote some good ideas like that. And there's some like, for example, version controlling your data, pinning your dependencies, having unit tests, or these are suggestions by Brian McFee, or for example, like reporting confidence intervals for results. That's not the like norm currently, but do you think it should be? And or do you have some other thoughts on like what you'd like to see adopted?
I think evaluation is hard because I think there are a lot of things that people would change about evaluation. Maybe when it comes to not always doing evaluation with like fully uppercase, non-punctuated transcriptions or reporting confidence intervals using different metrics, but these kind of things require like it's very hard to do them as like an or a domain-wide shift instantaneously. Like these are small things that are kind of gradually built on like currently we just use word error rate on LibreSpeech, but clearly this is only a snapshot of how an ASR model performs. And I think like a shift towards more thorough evaluation is something that would be pretty beneficial for the community, but something that cannot be done in zero shot. Like it's something that requires steps towards getting there.
The confidence interval stuff is technically a little bit tricky. I think in Kaldi we implemented something based on like matched pairs, something. It was some paper that someone had published. I think you can't just use the kinds of methods you'd use if everything was IID, because you know there's only a small number of things that are really confusable, and if you use like a super trivial formula, you end up getting too large intervals that are not useful. So it's just a little bit complicated, I think, to compute the intervals.
Yeah, at the same time, I agree that it's very important to promote good machine learning practices, like through our toolkits. Like, for instance, like I have been at InterSpeech, right? And you know, I saw so many papers like, okay, my model is 0.05% better than another one. Is that true? It's just like natural variability. What about the hyperparameter tuning? Like, imagine that you have a model, you compare two models. In one case, you do a hyperparameter tuning. In another case, you don't do it, or you do it very in a kind of bad way. So you can really compare the models. So yeah, I think you're right, Aku. Through our toolkit, we should promote as much as possible good machine learning practices. Not as Dan said, maybe it's not always immediate to do that, right? Confidence scores maybe requires to run many more experiments with different seeds, right? For instance, like, and see what is the variability in terms of performance. But you know, this is possible, but it requires a lot of computation, which normally we don't have. So, you know, sometimes it's not easy to implement in practice this like good machine learning practices.
I'll throw in one more there, which is always seed your random number generators, and just check for reproducibility. But more generally than the software engineering practices, confidence intervals, sure, if you have a reasonable statistical hypothesis that you're after. But more generally, I think there's too much showing of aggregate statistics and not enough showing of actual data. So rather than reporting a mean score, show the distribution of scores that you might get over your test collection. That'll give you a sense, not just on average, but in the full distribution, how two models might compare to each other. Yeah, that takes space. You can't fit 50 models in a giant table at the end of your paper. You have a figure that takes up more space, but you'll get a richer story and a better understanding of what your models are actually doing. So that's at least the sort of thing that I always bang on about when I'm reviewing papers. So if any of you have heard that from me anonymously, sorry, but that's how I feel.
Oh.
Okay, Vadim had a question.
Hi, yeah, so I'm coming from vision background, and also what I saw in the vision ecosystem, there's a ton of packages, frameworks, slightly different kind of goals, and that's very nice and like promotes different approaches, experimentation. But what would be nice there in vision and also in speech, from what I found, is to maybe actively look for repeated small low-level components and somehow try to upstream them to Torchaudio or some other very like small library, so that other frameworks that are currently developing, like SpeechBrain and others, can use those components. And those components, for example, can be tested by a funding company like Meta, and everyone benefits from that. And the same for kind of benchmark, holistic dataset benchmarks. If SpeechBrain succeeds, that's really awesome in hosting those challenges and benchmarks. But otherwise, having like some metrics, computation functions, very low level things, upstreamed is really useful for even for like when there's multiple frameworks. That's what I found in Vision. And just a comment about the ecosystem and the kind of different goals of and places of packages. And so I don't know what you think about this, but other than that, it's more of a comment. Thank you.
I think it's hard to have like a one size fits all, like even with like say like the basic attention module. I think that's going to differ in terms of like what each library is going to want. So like in the case of say like a library that needs to be extremely deployable and values inference speed, that's probably going to use a different implementation of the attention module to a library that really values code readability, and a library that has say like a single file policy like the transformers library, where we want to make it very easy for people to go in and hack and modify this code. So I think it fits like a certain demand and a certain niche, but I don't think it satisfies everyone in the regard that you can have a one size fits all here. Like I think each library has their own demands, which is why each library has their own variant of essentially the same thing.
A lot of what Librosa started out as was a collector of this kind of functionality that you're talking about, right? Like I started with MATLAB scripts that we had in the lab, and then I started pulling in scripts from other people's labs, and then started re-implementing other papers and finding what was common and trying to find an API that I could abstract out. And it's hard, grueling work. It takes a long time to do that. But yeah, that is exactly the sort of thing that I aim to do, at least.
Yeah, I think adding the evaluation metrics to Torchaudio is a good idea, so that the users can use the single function for their model evaluation. Yeah, and it also can set up a standard when people wants to do the research in this field. I think one example is the FAD metric that is recently added to Torchaudio, which is for evaluating the music generation or sound generation model. Yeah. But as you know, we only have 4 people in this team. So we would like to rely on the whole community to contribute to Torchaudio regarding those metrics. Yeah.
Okay, we are actually
one more question maybe, because we are going to be out of time.
Yeah.
The very last question I will say then.
Yeah.
Good, quite late.
Go ahead.
No, it's you, Sam, decide the one that you would like to pick up.
Is there a question? I mean, Adele has a comment. I mean, on my side, I don't have a question. I asked
Adele has a question, right? Like,
what
do you believe are maybe Adele? That's
Adele, you can ask Adele. Please unmute yourself.
Yep. Last question. What do you believe are the fundamental factors for maintaining the long-term success of an open source project, like such as Kaldi, for instance, of Librosa? What would be the advice that you would give like to other toolkits, such as SpeechBrain, for instance, or other like toolkit in the community to keep up in time?
I think Kaldi's been at it longer than I have.
Wait, I didn't quite understand the question. I'm sorry.
Like I was asking about how to make sure that your toolkit will not die in one day, you know, how to make sure that it will still be alive in the next
I
10
think
years.
the game has changed. Everything's moving so much faster these days that, like, you know, Kaldi lasted because for a while it was the only thing that was there, but I don't know. I think it's a lot about funding and stuff, and because the toolkit's not going to go away as long as you keep maintaining it, right? Some people are still going to be using it. It's a question of the funding environment.
But then, why do you think that Kaldi at some point killed HTK?
Well, HTK, I think it had reached an end of its line just from its own design limitations and the fact that it was in C. And I think Steve Young admitted that it was never intended to last as long as it did. It was surprising that it lasted as long as it did. It just was hard to extend, and eventually Kaldi ran into a similar problem. I think it's natural. There's a cycle of life and death for these things.
Do you think spinning off a new library is the best approach then, like doing the next gen Kaldi?
Yeah. Or sometimes, you know, even different libraries, like sometimes the whole structure of things changes and it doesn't have to be in one library anymore.
Yeah, I think the advice I would have is plan for rather slow changes. Like I mentioned at the beginning that I do about one major release a year, and I try to maintain backwards compatibility for a 3-year window and have long deprecation cycles. Because people work on research projects, yes, quickly, but also research project code grows and sticks around from one ICAST paper to an interspeech paper to another ICAST paper, right? You want these things to have some continuity and you don't have to go in and rechain, like update things so they work in the latest version, right? You want that to be as smooth and seamless as possible, which means paying attention to your upstream dependencies and making sure that the stuff that's coming at you down the road is going to maintain compatibility, and planning out your parameter changes and API changes and all that stuff. It's fiddly work and it's kind of painful, but it is worth doing if you want to have something that sticks around for a while.
Right. I guess that's it. If there are no more questions, we are kind of out of time. Thank you so much.
We are also very tired.
Yeah, I'm going to go to bed now. Back to bed.
I am
Bye,
tired.
everyone.
Thanks a lot.
Sam, what about if you conclude, right?
The closing remarks. Do we have slides for that, Mirko? No.
No. Just you can say hello to everyone, right? And thanks to the panelists, thanks to the speakers, thanks to the organization committee.
Thanks a lot, guys.
Hopefully we can collaborate.
For joining time with us.
Thank you very much again.
Nice to see you all. Bye. Bye.
Bye.
It was great. Thanks. Thank you, guys.
Bye.